When I first started learning trig substitutions, I kind of liked it. I liked trig. It was one of the few pieces of integration technique that I felt like I had some handle on back then. Um, so the idea of changing these integrals into trig functions was fun for me. But there was one reservation I had, and I want to share that with you and also share with you how I overcame that reservation. And that is on this first one right here. I'm going to make the substitution. I'm not going to do the integral, but because of the 1 minus x squared, I'm going to say let x equal sine theta. Right? Now, I felt like I was just then setting a restriction on x that I shouldn't otherwise. I mean, x is an independent variable here. This could be the integral from negative 17 to 95, for all I knew. However, when I say let x be sine theta, I have just restricted x severely. X can be no lower than minus 1, no bigger than plus 1. It's like how... The part of me was saying, you can do anything you want. And I say this many, many times to my students now. You can do anything you want as long as you do it right. That I can let x be anything I want, try plugging it in and seeing what happens. Take the consequences, whatever you let x be, then dx is going to be whatever it has to be. So I can let x equal sine theta if I want. It may not be any good, but still I just felt like I was somehow working with x's in ways that it shouldn't be worked with. However, it then occurred to me at some point along the way that this 1 minus x squared is underneath the square root, and that in order for this function to have any meaning, I need 1 minus x squared to be greater than or equal to 0, which tells me that, moving the x squared over to the other side, 1 has got to be greater than or equal to x squared, which means that x squared is less than or equal to 1, which means that x is somewhere between minus 1 and plus 1. So the notion of letting x equal sine theta is actually not a bad idea, because the function itself has its own restrictions. It has a domain of x is going to be between minus 1 and plus 1. So hey, x equals sine theta is probably a good thing to do. Right? Likewise, let's move down to the bottom one here. On this one, with the x squared minus 1, I'd be inclined to say let x equal secant theta. Right? And that actually just excluded x from being between minus 1 and plus 1. But yet again, I look at that and say, hey, that's under the square root. That means that x squared minus 1 has got to be greater than or equal to 0, which tells me that x squared has got to be greater than or equal to 1, which tells me that x is bigger than 1, or x is less than minus 1, which is exactly what the secant does. Okay? So these restrictions that are being imposed on it by your trig substitution actually turn out to be the restrictions that the function imposes itself. This one actually doesn't have a restriction, because if I look at, say, hey, when is 1 plus x squared greater than or equal to 0? Well, that's when x squared is greater than or equal to negative 1. Well, heck, x squared is always positive. It's bigger than negative 1. So that's no restriction at all. And when I make that x equals tangent theta substitution, well, the graph of x versus theta here for tangent looks like this. X goes from minus infinity all the way up to plus infinity. There's no restriction by this substitution. So where it may seem like you're putting a severe restriction on it, probably the function has that restriction on it anyway.